try to solve this differential equation. This is the second order differential equation, and it is non-homogeneous. And let us find the auxiliary equation first. The auxiliary equation corresponding to this would be, that is m square plus 4 is equal to 0. So the roots of this equation, quadratic equation, that is m is equal to plus or minus 2y. Okay. Now the complementary function yc would be, that is c1 cos 2x plus c2 sin 2x. So you got the complementary function here. Let us find what is yp here. So yp will be, that is 1 plus x square divides by, this is d square plus 4. Okay, now we got this. Let us try to simplify this. I'll take 1 by 4 outside, and I'll have in the denominator, which is 1 plus d square by 4. Look at this. Now it is multiplied with 1 plus x square here. So I get this. Now if I take to this to the numerator, so I get that as 1 plus d square by 4 to the power of minus 1. Okay, and it is multiplied with 1 plus x square. Okay, let us continue solving this problem. So if I bring on to the this power minus 1, if I expand that, so I get that as 1 by 4 into 1 minus d square by 4 plus d power 4 divided by 16, and so on, because I won't be it is not required, so power 4 becomes 0. So now let us try to multiply this, the first term with respect to first term. Okay, first term with respect to this. So I get 1 plus x square. Now let us put minus 1 by 4 here and try to find the differentiation d square. So that would be 2 here. I get 2 here. Okay, and the rest terms would be 0. So I wouldn't be using that. Okay, fine. So if I try to simplify it, so I get finally yp as 1 by 4 times that of x square plus 1 by 2. So this is your yp. So y is equal to yc plus yp. So I got this. Now let us move on to the next problem here. Now that is let us try to solve this, and now we have d square plus a square into y is equal to x square. Okay, now we have got the auxiliary equation corresponding to this, that is m square plus a square, which is equal to 0, and the roots are m is equal to plus or minus ai. Okay, so now we get the complementary function yc, which is c1 cos ax plus c2 sin ax. Okay, now yp would be, that is, x square divides by, let me write a square plus d square, right? Now if I take 1 by a square outside, so I get 1 divided by, this is d, let me write 1 plus d square by a square. Okay, now that is multiplied with x square. So that would be 1 by a square into 1 plus, this is d square by a square to the power of minus 1 and multiplied with x square. Let us expand this expansion here. So I get this as 1 by a square, that would be 1 minus d square by a square. Now the next term would be, that is, d power 4 divided by a power 4, fine, and this is minus, I won't be requiring the other terms because that goes to 0. So when you expand, when you multiply this, so I get 1 by a square into the first term, which is x square, kept like that, so minus 2x by a square, if I multiply that, so you get y is equal to yc plus yp. Okay. So this is that. So that's the solution for that. Okay. For any queries, you can ask. Okay.